Hello everyone, welcome to the first lecture on the CSAT 2024 course, and precisely this particular course or series would be in English. We have already started with the Hindi series wherein the audio is in Hindi. Here the audio would be in English. That's the only difference. Otherwise the content remains the same. Alright. Before starting with our lecture, I'll just give you the roadmap of how we would be continuing with our series. So as I've already discussed in the CSAT strategy video, that first up you would be covering all the important topics. And for us, considering the CSAT, number system seems to be the most important topic for all of us because it covers around 10 questions. Any paper, if we go back and see the trend, 10 questions are there from the number system and the other topics are interrelated with this particular topic. So what we have done is we are starting with the number system and we are starting with the first topic of number system, that is unit digit. Roughly around 10 lectures, if necessary we'll cover more than 10 lectures on this unit digit section. Now for any class related notes, study materials and the other updates related to the course and other various videos, you can join our Telegram channel wherein I'll provide you free notes. There's no fee or any monetary assistance that are required from you, just that you support me. Alright, just to give you a roadmap of how we would be continuing with our lectures. So for the first one, that is unit digit, we have divided this topic into 5 segments. We are starting with few basic questions. Then we'll move on to the cyclicity concept, that is the most important part of any unit digit problem. Then we'll talk about negative remainders or negative values in unit digit. Suppose we have a question as, upon solving a question, if we get the value as minus of 2, then what should be the unit digit in this case? So you would be tackling those questions as well. Then once we are done with these 3, then we'll move on to the pattern based or some miscellaneous questions. And as we all know that after these, I'll be giving you certain homework question that would be CAT level as well as certain higher level questions so that we don't lag behind. And in between these sessions, I'll be tackling certain PYQ of CSAT as well, so that our concept and this particular topic is all in all cleared. But there are certain things that I need from you. First up, you should be carrying a rough sheet of paper or a rough notebook while you're viewing this lecture. Without that, you shouldn't be viewing this. Also, if you can dedicate 1 hour, because the lecture is roughly of 1 hour from now, if you are starting the video, then only see this video. Otherwise, please keep it on pause and see it some other time. There's no point if you are not willing to put an effort. You should have a rough notebook with you, and that is how you should be viewing this lectures that we are uploading. Alright, starting with the first type, let's have a look at what type of questions can we expect in the basic type. So we can have a question as 456 into 23 into, let's say, 1289. Then they ask you what is the unit digit of this evaluation. And in terms of power based, it would be something like 456 to the power 23 into 23 to the power 19 into 1289 to the power 13. And then they ask you what would be the unit digit of this whole evaluation. Negative, I've told you. For pattern based, we can have a certain pattern of factorials, certain pattern of let's say basic squares, cubes, something like that, certain pattern. And with that, we'll also cover certain PYQ questions of CSAT. All right, starting with the first one, that is the basic type. And let's look at this question. We have 4 elements here. Whenever we need to find the unit digit, that means we are talking about the last digit from the rightmost side. Now if I ask you what is the unit digit of 19 plus 1, so you can simply add these two. So you'd be adding just 9 and 1, so you'd be getting a 0, and that is my LD or unit digit, the last digit. Unit digit can also be written as the last digit. Both of them are same. These are not two different things that we're talking about. So what we have learned here is whenever we are given certain longer expression, we can always break them down by their unit digits. So this whole expression can be broken down as 5 into 6 into 4 into 9 into 7. Now let's see what do we have here. 5 into 6, it gives me 30 and the unit digit seems to be a 0. Now here we have a very important concept. What is that concept? Now suppose when we talk about any multiples of 10, 10 and its multiples. Let's say if we have the value as 10 into 1 into 2 into 2 3 into 1 9, all of them would be having a 0, right? 2 3 0 1 9 0. Now if I multiply 30 in order to find the unit digit, this is what I would be doing. So if I multiply 30 with any of the remaining values, I would be ending with 0 as the last digit. So my answer is done. But if we want to solve it thoroughly, we can always do that. You can see 30 into 4, it will give me a 0 at the end. Then again into 9, it will give me a 0 at the end. Into again 7 will give me a 0 at the end. So this is how we solve it. And here we look at another important concept, and that is the concept of 0. When can we have a 0? For formation of 0, we ideally require a 5 multiplied with a 2. So if we talk about 5 into 6, it consists of 5 into 2 into 3. 6 can be written as 2 into 3. So for every 0, we need a product of 5 and 2. That is the most important part. We would be using this thoroughly throughout our session. So keep this point as the most important point. The concept of 0. For a 0, we need a product of 5 and 2. That is the bare minimum that we need. Alright, moving forward. Again, can we look at this? Can you give it a try? Do this. Pause the video, give it a try. So this can be written as 3 into 2 into 1 into 6 and into 4. Right? Let's start multiplying these terms. 3 into 2, 6. 6 into 1 is again 6. 6 into 6 we get 36. So I'm writing it as 6 because we are looking out for LD, which is the UD, and these two are the same thing, that is the last digit or the unit digit. I'll be using this term throughout the session, so get used to these terms, that is LD or UD, these are the same thing, and for both I'm referring to the last digit of this evaluation. Okay, now 6 into 4 is 24, so we would be writing it as 4, and this 4 is my last digit. Right? These are the basic types, right? Just get used to these problems. Then obviously we'll be talking about certain important questions. And trust me, if you just cover this video, your topic, that is unit digit, would be very easily covered. So bear with me for the next few minutes, at least, so that you get the knack of solving these questions. I feel up to now everything is clear. You're able to follow this. Let's move forward with this. Now, the digit in the unit place of the product. And what is the product that we have here? So we can write it as 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 and into 9. Right? Taking the unit digits. Now tell me, if we get a 0 in terms of product, that is a multiple of 10, any value would be ending in 0. So we can look at 5 and 6 easily, or 5 and 2. Let's look at 5 and 2 because I've told you a product of 5 and 2 will give you a 10. A product of these two will give me a 10. Now 10 multiplied with, let's say, 1 into 3 into 4 into 6 into 7 into 8 into 9 would automatically end in a 0 at least. So we know we are looking out for the last digit, and that is obviously 0. If we get a 0 in terms of the product, the last digit will always be a 0. This makes our calculation very easy. No need to go on calculating it. We can always do that, but We have to be very smart here while taking out these values. Alright, I feel this is clear to everyone. Any doubt? Clear? Okay, moving forward. Next one we have, now here type 2 starts, that is some difficult question based on these parts, but I'll try to keep this very simple for you. Alright, any number that we talk of, any number that we are talking about consists of different digits. And what are these digits? These are the digits from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this problem can be simplified as, no need to look at this problem, just look at the unit digit, that is 5. So this question becomes 5 to the power 5, 6, 4, 5. Next, it becomes 6 to the power 6, 5, 4, 6. Next, it becomes 4 to the power 3, 4, 2, 4. Next, it becomes 9 to the power 6, 5, 9. Then it becomes 7 to the power 7. So ultimately, if we understand the operation of these 10 digits, we can easily take up any question on unit digit. That won't be a problem for me, whether we are dealing with a 4-digit number or a 3-digit number or a single digit number. Ultimately, if I know how these different digits operate, I can easily tackle any question. Let's say if I know what happens to 5 to the power n, what would be the unit digit of this evaluation, I can easily take up these type of question. So one by one, we'll look at the different operation of these digits, and once we are good with these different operations, we can take up any question. So this is the most important part. If you're not carrying a notebook, trust me, this is the exact correct time to carry a notebook with you. All right. Now, let's talk about 5 to the power n, and in place of n, let's write down different random values. So if I write 5 to the power 1, what do we have? The unit digit 5. 5 square, what do we have? 25. 5 cube, what do we have? 125. 5 to the power 4, 625. Now another 5 to the power 5 or any other value that will always end in 25, or let's say the last digit will always be 5. Now let's start with 6. 6 to the power 1 is 6. 6 square is 36. 6 cube is 216. Like 6 to the power 4 would always end in 6. Now any value that is 6 to the power n will always end in the unit digit as 6. 5 to the power n will always end in unit digit being 5. So out of these elements, we can strike off 5 and 6 because we are done with these two. That means 5 to the power 465. I don't know the whole expression, but I know for a fact the last digit would be 5 and the second last digit would be 2. 25, 25, 25, 25. Or let's just focus on the last digit as of now. It will always be 5, the last digit. Or if we talk about 6 to the power 465. I don't know the whole expression, but for a fact, I know the last digit would be 6. That is 100% surety. Do you agree? Right? Can we have any other digits following the same rule? That is, we put any part to that digit, the unit digit would be the same as the base value. Think of it out of these options. Can we write 0 to the power n is also giving me the last digit as 0. 1 to the power n will also give me the last digit as 1. So again, these two are eliminated. What are we left with? Out of the 10, we have already eliminated 4. Now we are only left with 2, 3, 4, 7, 8, 9. Just 6 more. And then with that, once we deal with these 6 more digits, we are good with this part. That is the understanding of unit digit. And I'll give you an example. I'll show you how with this understanding you can actually solve questions that have been asked this year, that is 2023, as well as previously asked question. We can always tackle these once we have a basic understanding of these remaining digits. Okay, now let's talk about, okay, can we write this as further 5 to the power whatever it is, 5, and 6 to the power whatever it is will give me 6. Now you know 6 into 5 will give me a 30. Multiplied with any of these digits will always give me a 0 at the end. But let's see what would be the value of 4 to the power this value, 9 to the power this value, and 7 to the power this value. We'll also tackle these problems. Next up, we have 4 and 9. These two follow the same rule. That is, 4 to the power 1 will give me a value as 4. 4 square will give me 16. 4 cube will give me 64. And 4 to the power 4 will give me 256. What do we have here? We see that with 4, if I write an odd power, the result is always 4, the last digit. With 4, if I put an even value as the power, the last digit is always 6. Say this observation: 2, which is even, and 6. 4, which is even, and 6. 1 is odd, 3 is odd, and the last digit seems to be 4. This same rule is followed by 9. So 9 to the power 1 is 9, 9 square 81, 9 cube 729, and ultimately 9 into 9 would be getting a 1 here. So we can write 9 to the power odd value will give me the last digit as 9. 9 to the power even value will give me the last digit as 1. How many are remaining? Yes, this easy to solve. These are not very difficult. We are starting with an easier topic, but trust me, if you complete this, this topic would be very well cleared. Now, we have already covered 4 as well as 9. Out of the 10 digits, we have already covered 6. How more? 4 more to go. Can we solve these two? 4 to the power, what do we have? We have an even value. So even if we forget what are these values, we can always do the basic calculation. Suppose I forget what is 4 to the power odd, whether it's 4 or 6. You can always take up the example of 4 to the power 1. That will give me 4. Or if you are forgetting about what will be the value when the power is even, take the simplest value, that is 2. 4 square is 6. 9 square is 81. So 1. That is how we can always correlate and learn this concept for once. Now, 4 to the power even will give me the value as 4 square, which is 16. So I am writing here 6. 9 to the power, we have an odd value. So if 9 to the power an odd value, this will give me 9 to the power 1, which is 9. You can always correlate this. 6 into 5, 30. 30 into 6, 180. 180 into 9. So we would be ending with a 0. We have already got our answer, but let's just continue with it. I know the answer for this expression, it is 0, the last digit. Because we are getting a 0 with the product of 5 and 6. No need to solve this. There's no point solving this. But then again, let's do this for once and all. Now we are starting with another important one. And here we'll talk about the divisibility rule of 4, the cyclicity concept. It involves the divisibility of 4. Now let's just look at these terms. 2 to the power 1 is 2. 2 square is 4. 2 cube is 8. 2 to the power 4 is 16. So I'm taking 6. Now this 2, 4, 8 and 6 is being repeated every time. 2, 4, 8 and 6. Again, it would be 2, 4, 8 and 6. And how do we know how these elements are being repeated? So what we do, we divide the power by 4 and we look at remainders. Very important part, please pay attention. 2 to the power n, or let's say this is power, so I'm writing here p. Now what you do, you divide power by 4 and you focus on remainder. If the remainder is 1, then the last digit in that case is 2. If the remainder is 2, the last digit is 4. If the remainder is 3, the last digit is 8. If the remainder is 0, the last digit is 6. This is the rule that we follow, and we can always take this as part of information. Can you follow this? Let's see. Suppose we take up any value, let's say 2 to the power 7. Now, what is p here? P here is 7. So So what we need to do, 7 divided by 4. What is the remainder? 3. If 3 is my remainder, what is the unit digit? 8. Let's cross verify. 2 to the power 7. The unit digit seems to be 8. 3 is my remainder, therefore the last digit is 8. Can you do that? So now let's talk about the divisibility rule of 4. For checking whether a given number is divisible by 4 or not, we only focus on the last 2 digits of the number. The last 2 digits of n or the number. If these are a multiple of 4 or if these two are double zeros, then these numbers are divisible by 4. For example, 256, or let's say 13256, we only focus on 5 and 6. Another example is 420. We only focus on 20 because 20 is divisible. Now 444, we only focus on this part. Irrespective of what I write here, if the number is, let's say 1, 2, 3, 4, 4, 4, even then it is divisible. If I write here 7, then again it is divisible. Or if I write this as 13200 or 400, 712300, these values are again divisible by 4. These are the divisibility rule of 4. Next lecture would be on, lecture 2 would be on divisibility rule, wherein I'll be covering this in detail, the divisibility rule of different numbers. But for now, just keep this in mind. You need to divide the powers by 4 and focus on remainder. And based on the remainder being 1, 2, 3 and 0, that means if it is divisible, we write it as 2, 4, 8 and 6. 2, 4, 8 and 6. Are you able to follow this sequence? Now this will be repeated for 3, 7 and 8. Same process. We need to divide them by 4 and look out the remainders, and accordingly we'll write the values that we have. So again, I'll just revise these concepts for you so that you have a better understanding of this. Talking about the digits is 0. Just make it a pointer, make it as pointer 0, 1, 5 and 6. The last digits are 0, 1, 5 and 6. 4 and 9, 4 to the power odd is 4. 4 to the power even is 6. 9 to the power odd is 9. 9 to the power even, we have 1. Are we done with this? Now for 2, 3, 7 and 8, we follow the cyclicity of 4. So why do we call it cyclicity? Because these keep on repeating after every 4 cycles. So for 2, we get the unit digit as 2, 4, 8 and 6. For 3, it would be 3 to the power 1, 3 to the power 2, 3 to the power 3 and 3 to the power 4. That is 3971. For 7, it is again 7, 49, 343, 2401. And accordingly, we can solve this. Let's do few questions here. For 2 to the power, quickly solve for these two values, 2 to the power 23, 2 to the power 32. Do this. So you can divide 23 by 4. What is the remainder? The remainder seems to be 3 and therefore the last digit is 8. In the next case, 32 divided by 4, it is divisible, so the remainder is 0. If the remainder is 0, we write the last digit as 6. Clear? Let's move forward, because this needs to be understood and you have to do certain calculations here so that you get used to this. And trust me, once you are done with this, you can very easily solve these questions. 3971, as I told you earlier, 3971. So if we talk about, we divide this by 4, the powers must be divided by 4 and we focus on remainder. So if the remainders are, once you divide any value by 4, you can have the remainders in this possible range, that is 1 or 2 or 3, or else it would be divisible, so I am writing 0. Last digit in these 4 cases would be 3, 9, 27, so 7 and 81, so I am writing 1. Now tell me the values for 3 to the power 289, 3 to the power 81, 3 to the power 246. Quickly. Divide these powers by 4. So if you divide 89 by 4, you can simplify this as 3 to the power 1 because you are getting the remainder as 1. Now what is the value of 3 to the power 1? You know the last digit is 3. Very easily you can solve this. 81. If you divide, you will getting the remainder as 1. So you can write it as 3. 246. Remainder would be 2. So 3 square is 9 and that would be the last digit or the unit digit. I hope you are able to follow this. If yes, then let's do one more question real quick. What is 3 to the power 101 or let's say 103? 103. This can be broken down as 3 to the power 3, which is 27. So the last digit seems to be 7. That is how easily you can take up any question and solve this. I feel this much is clear to everyone. You are good to go. Till now you are following everything, no doubts anywhere. If you have any queries, any doubt, do join the Telegram channel and we can have a productive discussion there, or you can always comment your doubts in the comment section. That is where we can have a productive discussion. Now, 7. So we can have the unit digit as 7, 9, 3 and 1. And this should be repeated 7931, 7931, 7931. So again, I'll just write the remainders. If the remainder are upon dividing it by 4, 1, 2, 3 and 0, the last digit would be as 7, 9, 3 and 1. This column needs to be, and no need to memorize this. You simply know these values, right? What is the value of 7 to the power 1, 7 square, 7 cube and 7 to the power 4. You can always remember them. Tell me the value for 7 to the power 47, 7 to the power 283 and 7 to the power, let's say, 65. Now, first up, can we write this as 7 cube? Because if you divide 47 by 4, the remainder seems to be 3. Now, what is 7 cube? 343. So, what is the last digit? 3. 283 can again be written as 3 cube because 83. Next, it is 343. So, I am writing 3 as the last digit. 65. 7 to the power 1, which gives me 7 as the last digit. Do you agree? Alright. Moving forward. Similarly, we have the case of 8, wherein if the remainders are 1, 2, 3 and 0, we get the last digits as 8, 4, 2 and 6. I hope this is clear. Alright, now quickly tell me the value for 8 to the power 4092556 and 8 to the power 213. Now we only focus on the last two digits. Is 56 divisible by 8? Yes, 56 is divisible by 8. So this can be written as 8 to the power 0. And what do we have here? Or 8 to the power 4. And what do we have here? The last digit as 6. Now 213 can be written as 8 to the power 1. And what is the last digit? That is 8. Very easily we can tackle these questions. I hope you are following this and you don't have a doubt here as of now. If any doubt occurs, please comment. I'm there to help you clear your doubts. Coming back to this part wherein we have left this question. Okay, I'll just do it once again. First step, reduce this in the form of single digits or unit digits to the power different values. Now tell me quickly everyone, because now we are done with all the different digits. Now let's do the questions. 5 to the power any value will give me the unit digit as 5. 6 to the power any value will give me the unit digit as 6. 4 to the power an even value, 4 square is 16, so I'm writing 6. 9 to the power an odd value, so 9 to the power 1 will give me the unit digit as 9. 7 to the power 7 can be written as 7 cube. And what is 7 cube? 343. So tell me the unit digit. 9 into 7, 9 into 3, 27. 7 into 6, 42. 2 into 6, 12. And 2 into 5, that is 0. So the last digit seems to be a 0. We have already discussed this. That is, we can always start with these two and we can take up the last digit as 0. No need to calculate this. Not required, but even if we do, how easily we can answer this. Alright, so let's move forward and let's be done with few more questions real quick. Okay, what do we have here? These are based on, yes, this was asked in this particular year, 2023. Let's see if we can do this. What do we have here? This question can be reduced as 2 to the power 9 into 7 into 5 into 3 into 1. Or this can be written as, let's multiply this. 9 into 5, 45. 7 into 3, 21 into 1. So let's just omit it. 45 into 1, 45. 45 into 2, 90. So this whole expression becomes 945. I'll just write here 945. 2 to the power 945. Now you know 2, 3, 7 and 8 follows the cyclicity of 4. So we need to check what do we have here. This can be reduced further as 2 to the power 1 because upon dividing 945 by 4, you get the remainder as 1. What is the unit digit? The last digit of 2 to the power 1 is 2. So we'll mark it as option A and that is my correct answer. How easily within, let's say, 30 seconds you could have solved this once you know the concept, right? So if a question like this occurs in your further examinations, whichever exam you're targeting, please mark them correctly and with 100% efficiency because this unit digit or last digit is a easier topic to tackle. Alright, so let's do one more. This was asked in the year 2021. 3 to the power 2019 is divided by 100. Then what is the remainder? Oh, okay. Let's just cut this part for now. I'll tell you why did I take up this question. It's a remainder question, but why have I kept it as part of unit digit? You will get to know once we start with the solution. Okay, tell me the unit digit for this. What is the unit digit of 3 to the power 2019? Can we write it as 3 to the power 3? Because if you divide 2019 by 4, you get the remainder as 3. And what is the last digit? 3 cube is 27. So we take the last digit as 7. Right? Now, we are done with this part. Now, the question, actual question. What is our actual question? Our actual question is, if you divide 3 to the power 2019, this will give me a value. If you divide this by 10, what is the remainder in this case? Right? Now, I'll ask you certain questions here. What if I write here 7 divided by 10? What is the remainder? 7. If I write 17 divided by 10, what is the remainder? 7. If I write 232 divided by 10, what is the remainder? 2. If I write 10 divided by 10, there is no remainder, so I'll write 0 as the remainder. 100 divided by 10, the remainder seems to be 0. 2431 divided by 10, the remainder is 1. 5462 divided by 10, the remainder is 2. So in all of these cases, we can see whatever the unit digits are, those becomes my remainder when you divide this value by 10. These are the last digits respectively, and if you divide this values by 10, the remainder is also those last digit. So what is the last digit of this evaluation? Just now we have solved it, 7. So if we divide it by 10, the remainder is also 7, and that is how you could have marked this as option C, which is 7. I hope this is clear to everyone. 2 questions. Just now we have learned the concept, and very easily you can tackle these questions once you have understood the concept really well. I hope you are making notes of these pointers and you are going through it as I am continuing with the session. Alright, moving on to the next one. We have a symbol here, right? I'm tackling all the CSAT pre-IQ questions because we are done with this topic. We'll take up different questions as well, certain challenging questions as well, but for now, this is what we are tackling. In place of this, can I write here A? Just in place of box, I'm writing A, right? Just for better understanding. Let's see. If I add them up, A plus 1A plus 5A plus double A plus A1, upon adding we get it as A and 1. Now we'll use this information and we'll use the different values given to me to answer this question. What we can do here, we can see here it is A, so A is equal to 1 2 3 4 times A plus 1, this expression. Now you will use different options to solve this. Suppose I use option 2, so A value is 2, this is 8 plus 1, which is 9, does not match. Now B, 3, so this is 4 3s are 12 plus 1, we get it as 3, this matches, so this is my answer. But let's just quickly check 3 and the fourth option. 4 4s are 16 plus 1, we get 17, does not match the unit digit. 5 20 plus 1 21, does not match the unit digit I'm talking about. These does not match. 2 and here we have 9, does not match. 3 and 3, it matches, that is my answer. 4 and here we are getting 7, does not match. 5 and here we are getting 1, does not match. That is how you can solve this. Once you write this down, have an equation of your own, and then put the values and solve this real quick to get to the solution. A similar question was also asked in the year 2018, so I'll give it as homework. You can do this similar question, just in place of these symbols, dots are used. Alright, try this on your own. I feel you can easily solve this. Pause it, do it now. Alright, I'm giving you 1 minute, try to do it now. Alright, I hope you are done with this. Moving forward. Now, can we solve this? Let's see. This can be broken down as 3 to the power 4, 5, 6, 3 into 2 to the power 5, 6, 7, 4, 3, 2 into 1 to the power 4, 3, 1, 6 to the power 8, 7, 6 and 4 to the power 4. Now, we can always start with easier values, that is 1 to the power whatever can be written as 1, 6 to the power whatever can be written as 6. 4 to the power an even value, that is 4 square, which is 6. So we are done with these 3. Now let's come back to the first 2. 3 and 2 follows the cyclicity of 4. Cyclicity of 4, that means we need to divide the power by 4 and look at the remainder. So this can be further written as 3 cube, which gives me the value as 27, the last digit. And what about 2? 32, that means it is divisible, so 2 to the power 4. 2 to the power 4 is 16, so it is 6. This can be written as 2 to the power 4, and which will ultimately give me the value as 16. So we have, what do we have here? Let's just multiply this and let's get to our solution. So we have 7 into 6, 42. So I'm writing 2. 2 into 1, that is 2. 2 into 6, 12. And again 6 into 2, which is 2. So what is my last digit? That is 2. Right? Or we could have also tackled this as 6 into 6 into 6, so this is 6 cube. So 6 to the power any value, that would be 6. So up to now this is just 6, and 7 into 6 is 42. So you could have easily written it as 2, because 6, no matter what do you have in terms of powers of 6, the unit digit will always be 6. So then expression of this part can be reduced as 6, and then we have a 7. 7 into 6 is 42. So you can do it anyways. It's upon how easily you can solve it. Whichever ways is suitable to you, you can use those methods. Moving forward. Find the unit digit of the expression. Now here we are starting with certain negative as well. So let's see what do we have. Quickly, 3 to the power 23 can be written as, this part can be written as 3 cube plus 2 to the power 72 means we are writing 2 to the power 4 minus 5 to the power whatever, the value is 5, so I'll write 5. 9 to the power an odd value, that is 9 to the power 1, so it is 9. 4 to the power an odd value, 4 to the power 1. Now 5 and 4 gives me 9, and these two are eliminated. So what do we have here? 7 and 6. 7 plus 6 will give me 3 as the last digit. We are adding these two. I hope you are able to follow this. Any doubt, any queries? All good so far? Chalo, moving forward. Let's see what do we have here. 3 to the power 21 can be written as 3 to the power 1 minus 5 to the power any value will give me the unit digit as 5. So this is basically 3 minus 5, which is minus 2. So if you are getting the remainder as or the unit digit as minus 2, in that case the actual unit digit, actual last digit is always with plus 10. That is, minus 2 is what we are getting. We need to add 10 to this. So we'd be getting it as 8, and that is my correct answer. I'll just explain this. Suppose we are writing 13 minus 5. So do we actually write 3 minus 5? We don't write 3 minus 5, right? We write it as 13, and we write, or let's say if we write it as 232 minus 17. So we tend to take 2 as 12, and we write 12 minus 5. We don't take 2 minus 5. We write 12 minus 5, which is 5. And then what we have borrowed, we place it here, the one that we have borrowed. Therefore, whenever we are dealing with negative values, we tend to add 10 to it. Now, 2 to the power 97 can be written as 2 to the power 1 if you reduce this, minus 9 to the power an odd value can be written as 9. So this actually becomes minus 7, or the correct answer should be minus 7 plus 10, which is a positive of 3. And that should be my last digit. That should be my correct last digit. Are you able to follow up to now? I hope this is clear. Alright, moving forward. Now we are starting with the next or the last type of questions, that is the pattern based questions or certain miscellaneous question. This is the most important segment, so I request everyone to be very attentive now, because till now if you have paid attention, please be attentive for the next 5, 10, 15 minutes, and with that we'll wrap this up, and I'll give you certain homework question. As you can see, these are the homework questions that you have to try on your own. Alright, so let's start with this part, that is how we can tackle these miscellaneous questions that we have. Find the unit digit of all product of all the odd prime numbers. So now we are talking about prime numbers. Numbers divisible by 1 and the number itself are known as prime numbers. The first prime number is 2, next is 3, next is 5, next is 7, and then we have 11, 13, 17 and 19, and it continues. What I would suggest is you need to memorize all the prime numbers up to 100. Being an aspirant, you should memorize this part. For memory, we can keep it. Prime numbers are of the form 6n plus minus 1. So you can take up any value. These are from 5 onwards. These are not applicable for 2 and 3. From 5 onwards, every prime number is of the form 6n plus minus 1. And 2 is the only even prime number. Only even prime number. Other than 2, all the prime numbers are odd. All the prime numbers are odd. Is that clear? Any prime number that we talk about other than 2, these are all odd numbers. Now we need to look at the product of all the odd prime numbers. So we can start from 3 into 5 into 7 into 11 into 13 into 17 into 19 into 23, and this will continue. We are looking at what would be the unit digit. So we can start by multiplying these two. 5 into, what is our observation here? We have a 5 here. 5 multiplied with any value will always give me the unit digit as 5. You can check for yourself. 5 into 3, 15, 15 into 7, or 11, 15 into 5 into 11. Then again, if you multiply it with 3, you would be getting the unit digit as 5 always. Next, unit digit of the product of all the prime numbers. All the prime numbers means we'll be writing it as 3 into 5 into 7 into 11 into 13 into 17 into 19 and so on, and 2 as well. So what we have when we have a 2 and a 5, I've told you earlier, concept of 0. The concept of 0 says if we have a 5 and a 2 as product, we would be getting a 0. So the unit digit would be always 0 if we take up the product of all the prime numbers. These are not difficult questions, as you can see, and you can very well tell that these are always on the easier end to solve. These are not very difficult questions. Alright, chalo. Next, find the unit digit of the following. And what do we have as following? Questions based on 1 to the power 1, 2 to the power 2, 3 to the power 3, 4 to the power 4. Let's start by simple calculation. 1 to the power 1 can be written as 1. 2 square is 4. 3 cube is 27. 4 to the power 4, that is 4 to the power an even value, 6. 5 to the power any value is 5. 6 to the power any value is 6. 7 to the power 7 can be written as 7 cube, and 7 cube is 343. 8 to the power 8 can be written as 8 to the power 4, and 8 to the power 4 gives me 6. 9 to the power odd is 9. 10 to the power 10 is 0, unit digit. Now, let's write 9 and 1 as 10, 6 and 4 as 1 more 10, 7 and 3 as 1 more 10. What else do we have? Let's strike off this 0. So 12 plus 5 is 17. We have this as 47, or the unit digit is 7. Do you agree? Up to 10, if we go on doing this up to 10, we would be getting the unit digit as 7. Simple calculation, you can always keep this in mind. Now what if we write this in this order? So it would be 1 to the power 11 plus 2 to the power 12 plus 3 to the power 13, 4 to the power 14, 5 to the power 15, 6 to the power 16, 7 to the power 17, 8 to the power 18, 9 to the power 19, and 20. So 0 to the power any value, that is 0. Now, these two, 5 to the power, 6 to the power, 0 to the power, 1 to the power, will give me all those remaining values. So these are basically 1, 5, 6, and this is 0. 2 to the power 12 means 2 to the power 4, and 2 to the power 4 means 16. 3 to the power 13 means 3 to the power 1, which is 3. 4 to the power even means 4 square, which is 16, so 6. 7 to the power 17 simply means 7 to the power 1. 8 to the power 18 is basically 8 square, which is 64. 9 to the power odd means 9. Now, let's strike them off one by one real quick. 9 plus 1, 10. 6 plus 4, another 10. 3 and 7, another 10. Now we are again left with 6, 5 and 6, which is 17. So it also gives me 47, or we can write the last digit of this expression as well is 7. Now what is our observation? Our observation is, if we go on writing whatever the base is to the same power, base and the power is same, up to 10, if we do up to 10 starting from the first term, and if we go up to the 10th term, we get the last digit as 7. This is our observation. You see, 11 to the power 11, base to the power base, going up to 10 terms, and that 10 term should end in 0. We'll get the last digit as 7. That is our observation. Now it took some time, but for now, once you are done with this, you can easily follow this as part of your pattern. Therefore, we are calling it a pattern based question. Now what we can write? See, if we are getting it as in the form of base to the power base, can we write this as 1 to the power 1 going up to 10 to the power 10, 11 to the power 11 going up to 20 to the power 20, 21 to the power 21 going up to 30 to the power 30, then 31 to the power 31 going up to 40 to the power 40, and similarly 91 to the power 91 going up to 100 to the power 100. In all of these cases, the last digit is 7. All of these cases, the last digit is 7. So 7 must be added how many times? 7 must be added 10 times. 10 times. Or we can always write it as 7 into 10, which will give me 70. So the last digit here seems to be 0. If we go on up to 100 to the power 100, we can easily take up these questions. Right? I feel this is clear to you all. Right? These are all addition based questions, not multiplication. For multiplication, the answer would be 0 right from the start. If suppose we were asked in terms of multiplication. Now you tell me what would be the correct answer here if we are multiplying these terms. 5 into 6, 0, done. We'll be getting a 0. But since they are added, this is how we should be solving it. I don't think you have a problem here tackling these questions. Alright, let's move forward. How we can tackle these questions based on squares. Let's see quickly. 1 to the power any value is 1, 5 to the power any value is 5, 6 to the power any value is 6, and 0 to the power any value is 0. These are some basic observation. 2 square is 4, 3 square is 9, 4 square is 16, 7 square 49, 8 square is 64, 9 square is 81. Now let's add them up. Can we write here 9 and 1 as 10? Then 6 and 4 as 10. Again 9 and 1 as 10. Again 6 and 4 as 10. What do we have here? We are left out with 5. So you'd be getting the last digit as 5. And that is how we can mark these questions. The last digit being 5. Okay, next. If we look at this 11 to the power 2, 12 to the power 2, 13 to the power 2, 14 to the power 2, 15 to the power 2, going up to 20 to the power 2, or squares, these can be broken down as 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, and 10 square. And ultimately, this is just the previous question. So for these values, for squares, please remember this, for squares, going up to 1 square, going up to 10 square, the last digit is 5, whether it's 11 square going up to 20 square, this is also 5. Now again, if we want to go up to 100, so this would be 5 for every time, and how many times? 10 times. So this is 50, or the last digit is 0. Because see, 21 square going up to 30 square, again the unit digit is 5. So 5, 5, 5, 5, 5 going up to 91 square to 100 square, it will also give me 5. And how many times this 5 occurs? It is occurring 10 times. So if you add 5, 5, 5, 5, 5 or 5 into 10, we can get the unit digit as 0. And I hope this is clear to you all. An easy question to start with, because once we are good with these calculation, very well we can solve these questions, right? So moving forward to the next one. Now here we have to be a bit attentive, because for those who are from non-maths background, I feel factorial is an important concept that you should be tackling. What are factorial? Let's deal with factorials in detail. Now, factorials are given by this symbol, exclamation mark, or this type of symbol, right? So you can write 0 factorial, 1 factorial, 2 factorial, and we'll see what are these values quickly. 0 factorial is 1, sorry, not 0, it is 1. Number of ways of not doing something, that is 1. 1 factorial is 1, 2 factorial is 1 into 2, which is 2. 3 factorial is 1 into 2 into 3, which is 6. 4 factorial is 1 into 2 into 3 into 4, which is 24. 5 factorial is 120. And similarly, if we write 6 factorial, 7 factorial, 8 factorial, 9 factorial, 10 factorial, this is how we would be writing it. Just keep this in mind. 6 factorial would be 720. 7 factorial is 5040. 8 factorial is 4320. 9 factorial is 362880. 10 factorial is 3628800. Or we can write the factorials as 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial, all of these values. These are the same thing, two different ways of denoting factorials. What are these? Are part of permutations. Alright, I'll be starting with permutation once I'm done with number system. So in that I'll talk up in detail about this permutation. For now, let's just understand what are factorials, and we can just take up questions to tackle the problems that we have first hand. So for any value other greater than 4, that is from 5 factorial onwards, whatever these values are, these are always multiples of 4. So these are always in terms of 4n. Do you agree? See, 20, 40, 20, 80, 00. These are all divisible by 4. So 5 factorial onwards, all these values are divisible by 4. That is what we need to keep in mind. Alright, now let's come back to our problem. What do we have here, and let's see how we can tackle this question. 1 factorial, we know the value is 1. 2 factorial is 1 into 2, which is 2. 3 factorial is 1 into 2 into 3, which is 6. 4 factorial, the unit digit is 4. It is actually 24, but we are only writing the last digits. 5 factorial will end in a 0. 6 factorial ends in a 0. 7 factorial ends in a 0. 8 factorial ends in a 0. 9 factorial ends in a 0. 10 factorial ends in a 0. If we add these 4, what do we have? 6 plus 4, again a 0. So 2 plus 1, it gives me 3. So the last digit is 3. And this question is clearly similar to the previous one. So again the last digit would be 3. Because these are just two different symbols of factorial. What are the two different symbols of factorials? One is the exclamation mark, the other one is this value. Alright. So moving forward. Okay. Now, let's pay attention. Be very attentive now. This question can be written as 9 to the power an odd value. And what is the value of 9 to the power odd? 9 to the power odd means 9 to the power 1. So the last digit is 9. A pretty simple question. Next, we have a factorial sign here. So factorial sign means this value is 9 to the power in terms of 4n. Why we are writing it as part of 4n? See, from 5 factorial onwards, any of the value that we look at is divisible by 4. Right? That means all of them are even values. We can call it like that also well. So this is 9 to the power an even value, and 9 square is 81. So the last digit is 1. I hope you are clear with these two problems. Alright. Any doubt, please comment your doubts. I'll try to cater them. Next up, this is the most important part. Kindly be very attentive now. Alright. Now, we have a law of indices that says a to the power m bracket to the power n can be written as a to the power m into n. Right? But this is different from a bracket mn or a m into n. These are two different things. This is a separate thing and these two are separate. So how we can tackle these questions depends on how we can start with these problems. So for first up, if we write them as, let's say 20, what do we have? 24 to the power 7 and 8. 24 to the power 7 and bracket 8. These can be written as 24 7 into 8. So what do we have here? 24 7 into 8 is 56. Now this can be written as 4 to the power 56 or 4 to the power an even value. So 4 to the power even value gives me the last digit as 6. Next, 3 to the power 15 and 15. So this is 3 to the power 15 whole 15 can be broken down as 3 to the power 15 into 15, and we can write this as 3 to the power 15 into 15 is 225. So this is 3 to the power 1. So what is the last digit? The last digit is 3, and that is how we can mark these questions. I hope this is clear. This is one way of doing it. This is method number 1, wherein we'll use the law of indices to solve this. Now, if we want to do it with any other method, what we can do? Please follow method number 2 for solving these problems on law of indices. First up, we take the unit digit of this value. What is the unit digit of 3 to the power 15? This can be written as 3 cube, which is 7. Now, 7 to the power 15. So we'll write 15 here now. 7 to the power 15 can again be written as 7 cube, which gives me 343. So the last digit is 343. This was method 2 of doing it. Let's quickly look at method 2 for this question. So first up, we can break this. So this would be 4 to the power 7, which is odd. 4 to the power odd means the unit digit is 4. Now we'll write the higher value as the power of this. So this becomes 4 to the power 8, which is 4 to the power even value, which will give me the unit digit as 6. So the last digit seems to be 6. These are two different methods of solving questions which are of the form, please keep this in mind, which are of the form a to the power m whole n. If these questions are in this form, then you can use any of these two methods to solve the question. Alright, now this is not in this method, but if we put a bracket like this, then it becomes in this format and we can solve them. Alright, let's do this. I'm changing the question. This is not what you should be doing. I'm saying if the question was like this, then how will you solve? That is what I'm looking at. So this becomes 3 to the power 456 first up. can be written as 3 to the power 4 because 56 is divisible. So 3 to the power 4 means 81. Now 81 to the power 789 or 1 to the power 789 will give me the last digit as 1, and that is my answer. Or we could have used the method of 123 to the power 456 into 789, whatever the resultant was, and with that we would have calculated. That is another way of doing it, right? But let's say if our question was like this, 123 to the power 456 to the power 789, how we can solve a question like this? So I'd be discussing that in the next slide. I hope up to now these things are clear. So we'll start from this. That is 24, 7, 8, 3, 15, 15, 24, 7, 8. Suppose 24, 7 and 8. Right? What we can do? This question seems to be a question wherein 24 and this 7 is occurring 8 times. 7 into 7 into 7 into 7 into 7, 8 times. Do you agree? This part, this value is what we're looking out. So what is the value of this? This is the value. 7 to the power 4 or 4n will always end in 0, 1. Do you agree? A very larger value, but it will always end in 0, 1 or 1. Now 1 ending means it is 4 to the power. So this is basically 4 to the power an odd value, and 4 to the power odd will give me the last digit as 4, and that is my answer. Second question. 3 to the power 15 to the power 15. Again, what can be done? We can break down this value. So this is simply 15 into 15 into 15 into 15 going up to 15 times this value. So what is the exact value of this? Now let's start by certain multiplication. 5 into 5, 25 into 5, 125 into 5, 625. So we know the value is very large, but it will end in 25, the last two digits. So can we write this as 3 to the power, very large value ending in 25, and we just need the last two digits to solve it. So this can again be written as 3 to the power 1, which can be written as the last digit is 3. That is how you solve these type of questions. I feel you have a confidence now. How do we approach these type of questions? These are different from a to the power m whole n. Please keep this in mind. Alright, now let's do the last one. That is this particular problem, 123, 456, 789. If we have 123, 456, 789. What did I tell you? You can start with this part first. So if you see, this is 456 into 456 into 456. This is going 789 times. A very large value. But if we talk about this value, this whole value, this will always end in two digits. That would be a multiple of 4. Well, let's just see what are the values of 6 to the power different values. So we have these values as 6, 36, 16, and then again if we multiply, we would be either getting 56 or 76 or 96. All of these values would be divisible by 4. All of these values, actual values, these are divisible by 4 all the time. Yes or no? So whatever value we get, this whole value, since it is ending in either 16, 36, 56, 76 or 96, these are all divisible by 4. So these are of the form 4n. So we can break this as 3 to the power 4n. So this can be written as 3 to the power 4, which is basically 81, or the last digit seems to be 1. I hope you can solve these once you have an understanding of this part. And if you have any questions, do clear your doubts. But for now, these are your homework questions. I'd request everyone to at least give it a try. All of these 10 homework questions. You can join the Telegram channel wherein I'll be posting the class PDF as well, and any study material you can find it in our Telegram channel. The Telegram channel is Aptitude with Avishek Sinha. Alright, and if you find this video really helpful, kindly share it with everyone who you think would be needing these videos. See you all in the next video. Take care. Bye bye. Thank you everyone.